Okay, this should be review, Julian. 4x minus 3 times 4x minus 3. You write the two binomials side by side, and you've got to use that FOIL method. So you should get 16x squared. Then you get a negative 12x and another negative 12x, and at the end you get positive 9. Combine those middle terms, 16x squared minus 24x plus 9. Are y'all okay with that? That's it. Yes. Number 2 is also FOIL. Yes, you've got to do x plus 8 times 2x minus 3, and that's it. So you're going to get 2x squared. Then you would get a minus 3x and a plus 16x. That's going to combine to plus 13x. And your last term should be minus 24. So that's just remembering how to multiply binomials. All right, a lot of kids first and second period forgot how to do number 3. What is that 3 out in front? What are you going to do with that? I'm sorry, the 5 out in front. What is this 5 going to do? It's going to multiply by whatever comes out of the square root of 72. 72 is not a perfect square, but there are some perfect squares hiding in there, and we're going to find them and bring them out. And whatever comes out gets multiplied by the 5 that's already out there. So I'm going to start breaking down 72. I'm going to divide by the smallest prime I can. Now my hope is that as soon as you divide by 2, you should go, ooh, that's a perfect square right there. A lot of kids didn't recognize that and they kept going. That's fine too. You can. Now if you keep going, you're going to end up back at a 36 anyway, because I found a pair of 2's, which is a 4, a pair of 3's, which is a 9, and then there was a leftover 2 there. And put a 4 and a 9 back together, what is that? 36. Okay, so I'm going to rewrite 72. I'm going to rewrite 72 as 36 times 2 times that leftover 2. Now, what is the square root of 36? 6. I'm going to take the square root of 36, and the square root of 36 is 6. So a 6 comes out to join the 5 that's already out there. Becomes a 30 now. 6 times 5 is 30, and the only thing left inside the radical symbol is a 2. 30 times the square root of 2. Alright, and then number 4. I think the easiest thing to do on these problems is to move all of the variables to the top of the fraction bar first. And if anything ended up with a negative exponent, then you can move it back down. What is 18 over 12 reduced to? 3 over 2. You divide by 6 on top and bottom, you get 3 over 2. Now I'm going to move the x, y's, and z's. Edwin, you just really want me to say your name, don't you? To the top. So we're going to do the top exponent minus the bottom exponent. And some of you are having trouble with all these negatives flying around, so be careful. For the x's, it's negative 4 minus negative 2. These turn into a giant plus. What's negative 4 plus 2? Negative 2. For the y's, again, you can do top minus bottom. That's 3 minus 7 for the y's, which is negative 4. For the z's, it's 2 minus negative 5. Something really weird happens here. Becomes a positive 7. Now, on my final answer, the way they probably will put it on the end of course exam is they won't have any negative exponents. So the x to the negative 2 and the y to the negative 4 really should have gone on the bottom. So they become x squared, y to the 4th down here, and z to the 7th stays on top. That would have been the final answer. They might put the other one on all of the end of course exams I've seen over the last 5 years. This is the version they put. Question, yes. All right, now we are going to look at quadratic equations today, which we were doing that before we left for the holiday. That's our title, quadratic equations. What a quadratic equation will look like when you graph it is a parabola. You got to know that as well. And a quadratic equation is in the form of y equals ax squared plus bx plus c. So this is all stuff we've talked about already. A parabola could be a smile or a frown. Right, a happy parabola or a sad parabola. Nope. Now, we have been working with parabolas quite a bit before we left for the break. What was it that we were finding on a quadratic equation or a parabola? We were talking about domain and range, absolutely. What's the domain of any parabola, by the way? All real numbers. If you're looking at a parabola and I ask you what the domain is, it's always all real numbers when you've got these little arrows to the right and left. The range depends on where the vertex is, and we're talking about vertex today. But what else did we do forever and ever and ever? Roots, thank you. We were finding roots, otherwise known as x-intercepts, otherwise known as zeros. Patrick, thank you. Okay, so that's the things that we were focusing on before we left. The roots were the biggest thing that we found out so far about parabolas is we've dealt with roots, aka zeros, otherwise known as x-intercepts. That's the points we have been focusing on. On a parabola, there's all kinds of other important parts, though. Today, what we're going to talk about is the vertex of a parabola. That's another important part in the life of a parabola, is the vertex, right, Chris? Sit up and write this down, please. Now, just like roots, otherwise known as zeros, otherwise known as x-intercepts, vertex of a parabola also has several names. It's called a vertex. It can also be called a turning point. It can also be called either the minimum or the maximum. It cannot be both. It's one or the other. Now, the type of parabola you're looking at will determine whether it's a minimum or a maximum. If you're looking at a smiling parabola, a happy parabola, the vertex is always right in the middle. Would this be a minimum or a maximum? Okay, but this point on the graph, is it the highest point on the graph or the lowest? Yeah, this is a minimum. So if you're looking at a smile, it doesn't have a maximum because what's happening at the top, it's going on for ever. It doesn't have a maximum point. It does have a lowest point. It has a minimum. And if you're looking at a sad parabola, the vertex is at the top now, which is a maximum. So you will have to tell me whether it's a minimum or maximum. That's part of your homework. I'm going to make you tell me whether it's a minimum or a maximum. That's not it. Then you actually have to find out what it is. Okay, now, I'm going to do a little bit of like side information, and you don't have to write this part down. All of this you should have written down. In just a minute, we're going to talk about how to actually figure out the value of the turning point. The calculator can tell you how to do it, but we're going to do it by hand, by brain, and pencil and paper today. Okay, now, let's back up a little bit. I want to talk to you about functions in general. A function is anything that starts out y equals and has numbers and symbols and variables. That's a function. You could have simple functions like y equals x plus 2. That's a very simple function. The ones that we've been looking at are more like this. Y equals 2x squared plus 3x minus 5. That's what we've been dealing with lately. This one is called a quadratic function. This one is called a linear function. There's all kinds of functions. These are the two that are mainly focused on in Algebra 1. And I do want you to be able to look at an equation and tell me what kind of picture it's going to be. If you have y equals and you just have an x with no exponent on it, that's linear. Whether there's a number in front of x, whether there's something added at the end or not, that's linear. If you look at your equation and you've got an x squared in there and that's the highest exponent you've got, that's when you know you're going to have a smile or a frown. This kind of problem will just line up in a line. Okay? Now, on any function, how many solutions are there to a function? Infinite. There are millions of solutions to any kind of function you're looking at. These are just the two that are most likely to come up in Algebra 1. There are billions upon trillions upon billions of solutions. The solutions to any type of function are points. The solutions to functions are points. That's important. You don't have to write this down, but you just need to know it. How many points are on a function? Infinite. There's billions of points on a function. Okay, now, to find a point that's on any function, listen to how you find a solution. Are you listening? Andrew, are you listening? How many solutions are there to a function, Andrew? Infinite. Thank you. Now, the solution to any function is a point. That means an x value and the y that goes with it. So let's say we had this simple linear function. If I want to find one of the bajillions of solutions, Chris, on that function, do you have any idea how I would do that? You don't know how to find a solution on this? Nobody does? Okay, the nice thing about functions is if I ask you to find any random point and I don't make you find a specific point for me, you get to pick whatever x you want. Y is not an x. 3. Okay, so if one of the solutions to this particular function, well, not me, but Julian picked 3 for x. I have got to now take his x value, plug it in to find the y that goes with a 3 value of x. So instead of x plus 2, you're going to do 3 plus 2. What's 3 plus 2? 5. That's one of the bajillions of solutions to that simple linear function. Give me another one. Give me another solution. All right, you're giving me an x value of 57. What would the y value that goes with it be? 59, because 57 plus 2 is 59. Give me some small x values. 1 would give you back a 3. How about 0? 2. How about negative 1? 1. Now, I know this is linear before I ever started, and I knew it was linear because I didn't have any exponent on the x. Guess what would happen if I graphed all these points? They would line up in a line. 1, 3, 0, 2, negative 1, 1. They would all line up in a line. And any point on that line is a solution to the line. And yes, 57, 59 would be way off my screen. I just don't have enough space to graph it. So to find solutions to any function, you get to pick an x value, you plug it in, you do the math to it, and out pops the y value. A solution to any function is a point, an x number, and the y that's paired with it. Are you with me? Chris, sit up. Now, that was a simple linear function. We're going to be doing functions that are a little bit more complicated. I don't know what I had written down a second ago. Y equals 2x squared plus 5x minus 6, let's say. All right, I'm changing it. How do I know this is not going to be linear? Because it has an exponent of 2. This is going to be quadratic. That means it's going to be a smile or a frown. And I should be able to tell whether it's a smile or a frown just by looking at the equation. Can y'all tell me if it's a smile or a frown? This is going to be a smile. How do I know it's a smile and not a frown? Because the value of a, the first term, the x squared coefficient, is positive. If you have a positive number in front of x squared, you have a smile on your hand, a happy parabola. Are you with me? If you have a negative number here, then you've got a frown on your hands, a sad parabola. All right, now how many solutions are there to this parabola here? Billions upon billions upon billions. Infinite, yes, infinite. Yes, there are infinite solutions. Let's find one of those billions upon trillions upon trillions. Okay, now, keep in mind, a solution to any function is a point. An x number paired with a y number. Jesus, guys, y'all have got to sit up. Give me an x value, a simple one. 1, I like 1. Now, that's not a solution. That's part of a solution. That's the x value. Now, what do I have to find? The y that goes with it. So what am I going to do to find the y that goes with it? You're going to replace the x's with 1s. You're going to put a 1 in for x. And you're going to figure out what y is if x is a 1. So instead of 2 times x squared, you would do 2 times 1 squared. Plus, instead of 5 times x, you would do 5 times 1, and then you would have a minus 6 on the end. What in the parentheses? What now? Yes, absolutely. I'm finding one solution right now. I'm not. No. What changes as you change x is the number you put in for x. This 2 will always be in front of x squared for this particular problem. This 5 will always be multiplied by x, and you'll always have a minus 6 on the end. So what's 1 squared? Seriously? 1 squared is 1. And what's 2 times 1? 2. So this first cluster would be a 2. What's 5 times 1? And then minus 6. What's 2 plus 5? And what's 7 minus 6? 1. So 1, 1 is one of the billions upon billions of solutions. Does that make sense? Is it a significant point? Is it an important point? I don't know. But it is one of the solutions. My point is, I want you to understand how you find solutions to any kind of function. You pick the x, you put the x in, you do the math to it, and out comes the y that goes with that particular x. X was 1. Somebody told me to use 1. Okay, now keep that in mind for what we're about to do. We are about to find vertex, which a vertex is just a solution. It's just one of the millions of solutions to a parabola, but it's one of the most important solutions. It's either the highest or the lowest, and it's a very important critical part of a parabola. So that means you cannot just pick any random x value. Are you with me? I will tell you how to find the x value, and then you've got to figure out what y goes with that x value. This is the formula for finding vertex. This part you need to write down. And it should look vaguely familiar to you. It's the opposite of b over 2a. Anybody recognize that from? It's part of something. It's from the quadratic formula. Yeah, here's the whole quadratic formula. You don't have to write this down. It's part of the quadratic formula, but if you took away all that radical business, if you took all this stuff away. It's the opposite of b over 2a. And they will give you that. They will give you the x value, the formula for the x value of the vertex. That means I am no longer allowed to pick any random x value I want, because the vertex is a very specific point. It's not just any random point. Now, after you figure out the opposite of b over 2a, which is easy to do, it's not hard to do at all, how do I find the y that goes with it? Then you have to take that opposite of b over 2a, whatever you get there, you have to plug it into the formula. That's how you find the y that goes with it, like we just practiced. That's the equation for finding vertex. Boys, I am not amused. Alright, here is an example of what you're going to have to do for homework. Please also listen to my directions for homework. What we're about to do together is exactly what you're going to do for homework, no matter what the directions on the page say. You are going to, first of all, tell me whether the vertex is a minimum or a maximum, and then you're actually going to find the vertex. Nicole, set up. All right. I call your name at least 20 times a day. Jesus. All right, look at this. Look at this little function rule here. How do I know it's going to be a parabola? Because there's an x squared, and that's the highest exponent I've got. Now, what kind of parabola is it going to be? A happy one or a sad one? It's going to be a happy one, because a is positive 1. So am I looking for a minimum or a maximum? I'm looking for a minimum. On a happy parabola, it doesn't have a maximum. It goes on forever to the top. When it's happy, it's minimum. All right, now, so I'm going to label my vertex as a minimum. So I know that you know this is a smile situation, and we're looking for the lowest point, the turning point, the vertex. Now, you cannot just pick any random x value you want, unfortunately. You've got to pick the x value that is found by taking the opposite of b over 2a. And then you plug that in to figure out what y goes with it. Well, what is the opposite of b in this problem? Here's b right here. B is always in front of x. So if b is 4, what's the opposite of that? Negative 4. Over 2 times whatever a is. What's a in this problem? An invisible 1. Well, what's negative 4 divided by positive 2? Negative 2. I have just found half of the answer I'm looking for. I have found the x value of my vertex. That's the easy part, though. What do I still have to find? The y that goes with it. What y value is attached to an x value of negative 2? Well, the way I'm going to find that is I'm going to go back to my function rule, and I'm going to take the x's out and replace it with a negative 2. So I know what x value I've got to use now. I've got to use negative 2. That's half of my vertex. Now I'm going to go back to this function rule, and anywhere I see an x, I'm going to put in a negative 2. So I'm going to do y equals negative 2 squared plus 4 times negative 2 minus 5. What is negative 2 squared? 4. Now my next cluster, what's positive 4 times negative 2? Negative 8. And then bring down the minus 5. Keep on going. What's 4 minus 8? And what's negative 4 minus 5? 4 minus 8 is negative 4. What's negative 4 minus 5? Negative 9. There's my vertex, and I already determined it was a minimum. That's what I want to see for your answer. Christopher, you should be doing this with me. So on your homework, I should see all this work, no credit. I should see whether it's a minimum or a maximum. And then I should see, if I am talking, you should not just start talking. So this is exactly what I want to see for your homework. You wrote the question, you did the work, you labeled it a minimum or a maximum, and then you told me what the vertex was. Now, in a minute, we're going to put the calculators on your tablets. Okay, so you'll have access to them at home. I know you don't have a calculator right now on your desk, but just please look up here with me. I am going to look at this in the calculator. I'm going to look at a picture of this parabola. Y equals x squared plus 4x. And then what was it at the end? Minus 5? Okay, you should have already been doing it with me. All right, then graph it. It is a parabola. It is a smile. Does this look reasonable that the vertex, the minimum point, could be at negative 2, negative 9? It looks reasonable to me. Go down left 2 and down 9. That looks reasonable to me. And if you look at the table of values, if I look at negative 2, well, first of all, let's look at negative 2. Is it match with the negative 9? And then look what happens around it. Do you see how the points start repeating? Because the negative 2, negative 9 is in the very middle of this graph. So if I go one space above it or below it, I get the same y value. You see what I'm saying? That's the middle of the graph. Okay, so I feel pretty good that I did that correctly. Let's try another one, number 2. Number 2, y equals negative 2x squared plus 8x minus 5. How many solutions are there to that? Millions, infinite. How do I find solutions? How do I find solutions? You pick x's, you plug them in, and you find the y's that go with them. I'm not interested in random solutions today, though. Today I'm interested in one particular solution called a vertex. Now, is this a smile or a frown? This is a frown. So am I looking for a minimum or a maximum? I am looking for the highest point on this whole graph. That's a very important part of a parabola. Andrew, you should be trying this. Christopher, you should be trying this. Do this, yes. Now that means I cannot pick any random x value that I want. I've got to pick a very specific x value. How do I find the x value that I need to pick? Opposite of b over 2a. And then I take that answer, I take that x value, and plug it in and find the y. So I'm going to do negative 8 over 2 times negative 2. What is my x value? Yeah, negative 8 divided by negative 4 is 2. If you mess up on the x value part, anything you do after that's going to be wrong. So be very careful with your signs and everything. The opposite of b would be, here's b is 8, so the opposite of that would be negative 8 over 2 times a. 2 times negative 2 is negative 4, and negative 8 over negative 4 is positive 2. I'm halfway done now. I'm halfway done. I know it's a maximum. I found my x value. I still need to know what y goes with an x value of 2. What do I do now? You plug a 2 back into the original problem. Wherever I see an x, I put in a 2. Do that. I'll race you. On your market, set, go. Oh, y'all are already done? Okay, you just called out. Did you get 3, Edwin, or did you just call it out because other people were calling? Well, then keep working, because I don't know if it's 3. Maybe they're wrong. Okay, I got 3 as well. So this is what I would expect to see on your homework, where you this is the final answer, but I also need to see all the work you did to get there. And you need to tell me if it's a minimum or a maximum. All right, I'm going to just check myself on my handy dandy calculator. I'm going to put the function rule in. Y equals negative 2x squared, whoops, plus 8x, oops, and then at the end, what was it? Minus 5. Okay, I'm going to look at a picture. First of all, make sure I know if it's a minimum or a maximum. Definitely have a frown situation. Definitely looking for a maximum. Does 2, 3 look reasonable? It does to me. If I go right 2 and up 3, that looks like I'm right at the vertex. If I look at the table of values, 2, 3 should be kind of in the middle. It's where the points start to mirror each other. 2, if I put in a 2, I do get back a 3, and sure enough, look around that point, and they do start to repeat each other. You see what I'm talking about? No, not necessarily, because the ones that we're doing today are nice, whole numbers, but that's not always going to be the case. I will show you how, on the ones on the homework today, I want you to do by hand. Tomorrow, or for you guys, I guess Wednesday, I'll show you how to do it on the calculator. All right, you try this one, please. Number 3. Oh, then Thursday. All right, first of all, tell me if it's a minimum or a maximum, and actually find the vertex. Go. Do it. Andrew, unroll your paper, pick up your pencil, and do some math. Christopher, sit up. If I call your name one more time, I'm calling your mother. Edwin, if I see that hood up one more time, I'm giving you detention. Get busy, Christopher, now. Do this problem, Edwin. I got negative 1 as the x value. And if you mess up there, guys, anything else you do after that's going to be incorrect. So now you're going to do 2 times negative 1 squared plus 4 times negative 1 plus 7. You want to do these clusters separately and then combine them all at the end. Negative 1 squared is 1, and 1 times 2 is 2. This second cluster becomes a negative 4, and then bring down the plus 7. 2 minus 4. 2 minus 4 is negative 2. And negative 2 plus 7 is 5. So your final answer, you would label it minimum, and you would circle your answer negative 1, positive 5, and I better see the work where you got that. Yes. Okay, are y'all with me here? Alright, now I am going to tell you what the homework is. Please pay attention to what I'm about to say. I have had more than one person do the entire set of wrong questions. It's page 444. It's in the written exercises. And please do not listen or do not pay attention to what the directions say. I told you exactly what I expected to see. You either label it minimum or maximum, you find the vertex, and you show your work. You are doing 1 through 10. Please make sure you're doing the right number 1. I'm even going to tell you what number 1 should say, so you make sure you're starting on the right set of problems. Number 1 should look like this. Y equals x squared plus 6x plus 8. And ignore the directions. You label it minimum or maximum, you show me the work, and you find the vertex. Now, I'm still not done with you guys. I want to show you how to put the calculator onto your tablets. If you don't have it, then you need to write down these directions. Okay, now, let me talk to you about the calculators. I need y'all's attention. After tomorrow, after the PSAT, you will be given homework that requires the use of a calculator. In class, I will obviously provide you with a calculator, but you will have homework problems where you're going to need to use a calculator to find the answers. It's not going to be optional. So, the two top choices, I would say, my number 1 choice is get a graphing calculator. It's going to be a good investment for your future anyway. My second choice would be to put a graphing calculator, a TI graphing calculator, a TI83 graphing calculator onto your smartphone. Some of those cost money, but it's still a lot cheaper than an actual TI83 calculator is. My first choice, get your own calculator. Second choice, put it on your smartphone. Third choice, which we're going to do right now, we're going to put it on our tablets. So at the very least, you should be able to access a calculator on your tablet after today. And there is going to be no excuse of I couldn't do my homework because I did not have a calculator. We're going to go through all the steps right now. If you don't have your tablet with you, watch this later or write down the instructions. Get out your tablets and turn them on and get to Google. What? No. Walmart, Best Buy, Target, they're about $100 to $125. Office Depot has them. Okay, now certain browsers weren't working for this. I don't think that Explorer will work. I think you need Google Chrome to do this. Somebody's, I don't know, somebody's was. Okay, so get to Google. Everybody get to Google, and this is what you need to search for. TI83 online calculator. That's what you need to search for. Now, I really don't want you to go higher than a TI83 because, unfortunately, folks, the intermediate campuses are not given the latest and greatest calculators. On the day of the actual end-of-course exam, you will probably be given an older style TI83 calculator. So I really don't like you practicing on one that's far advanced because that's not what you're going to see on test day. I want you to be used to what it is you're going to get on the test day. Just listen, just start your homework, and you'll have to watch the video later. Okay, so once you get to Google TI83 online calculator, you want to pick the one, it should be the first choice that comes up, that says TI83 interactive calculator Google Sites. That's the one you want to pick. Then click on that. And it comes up with some directions on what to do, and over here on the left, you want to click on where it says calculator. Now we're going to have to do this process twice. You want to hit download, and then it should download over here on the bottom left. If you click that, a folder is going to come up. Open the folder. 3 things come up when you open the folder. You click on the very bottom one, the TI83. Click on that one. Okay, and it's going to ask you to, you want to hit extract all, and then you hit extract when the next thing comes up. Now it's going to go right back to that same screen. You click it again, and now there's 3 things in that folder, but now the icon should look a little bit different. You want to click the third one again, hit run, and the actual calculator should pop up. If you want to save it to your taskbar, you go down to the icon on the taskbar, you right click it, and you put pin to taskbar. Then you have a calculator at your disposal on your tablet. Okay, so let's go back through those. You want to go to Google. You want to Google TI83 online calculator. You want to pick the one that says Google Sites TI83 interactive calculator. Come over here to the left, click on calculator. Download. Once it's downloaded, click on it. Open this folder. Pick the third choice. Extract all, and then extract. And then that folder is going to come up again. Then click on the third choice again, and then hit run, and then the calculator should pop up. I'll come around and help you in just a minute. If you're, some kids when they hit download, like nothing happens, and it's either that you need to update your computer or choose a different browser. Those were the 2 things that were happening earlier today if it's not working. Some kids when they hit download, it just never does anything. Okay, I'm going to stop the video. I'm going to come around and help you if you need help. If you didn't have your tablet today, you better get on this at home on your own. Was anybody able to get it? Okay.